Okay, in the last class, I started with a little bit of multi-rate signal processing stuff, because I said that when as such you do unfolding, then if the original DFG had some complexity, hardware complexity, then if you unfold by j, integer factor j, you gain in speed by a factor j, but the hardware cost goes up, because hardware gets replicated j times. So, hardware cost goes up, power consumption goes up, in general j times by j times. But then I said also that in certain cases, like an FIR filter, if you parallelize it, if you unfold it by factor j, we can employ some tricks by which hardware cost will not go up by the same factor j. It will go up, of course, by a factor much less than j, by some DSP tricks. That is what, this is a very interesting thing, and that is what brought me to this topic, and that uses concepts from very basic things about multi-rate signal processing. Last class I considered signal expansion, that is between every pair of samples you insert new sampling points and put zeros there, maybe capital M minus 1 number of zeros between every pair of samples, that is called an expanded sequence. Expanded sequence has a Z transform equal to original Z transform with Z replaced by Z to the power M, capital M, if you are plugging in M minus 1 zeros between every pair of samples. That is, if M is the factor of expansion, then capital X Z to the power M is X E Z. That is, expanded sequence Z transform is, this is X Z is the expanded sequence. This was done. There is one more issue called decimation, downsampling by an integer factor m. D for decimation, it means that suppose you had sequence of samples. This is the mth sample, 0th, 1, 2, dot dot dot. Then again many samples. This is 2mth. Zero, minus 1, all that. Okay. Now, if I select this sample, this like that, that is 0th, mth, 2mth, 3mth, minus mth, and bring them here, then I have got x 0, then mth sample occurring now at position number 1, first sample, which is x m, then at position number 2, x 2 m, dot 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 dot. On this side at position number minus 1, x minus m, at position number minus 2, x minus 2 m, dot 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 dot. Okay. This is called decimated sequence, decimation. By factor m, m is an integer, either 2 or 3 or 4, m1 has no meaning, you get back the same thing. So, actually what it means, if it were actually obtained by sampling an analog signal like this, I am throwing away these samples. So, I am basically sampling here, then sampling here, sampling here, sampling here. So, I am bringing down the sampling rate, increasing the sampling period by a factor capital M, or bringing down the sampling rate by a factor capital M. It is called decimation, decimation by a factor M. The sequence that is generated x d n is related to x n by this, that is x d n, it is any nth sample, it is nothing but original sequence at n into m. Okay. Like x d 0, x 0 into m, that is 0, x d 1, that is x 1 into m, x m, this is x d 1, x d 2 here, 2 into m, x 2 m, so on and so forth. All right, these two basic operations. Then I go for Let me erase this. Suppose I have a sequence the sampling points are, this is 0, sorry, this is 0, 1, 2, this is m minus 1, this is m, this is m plus 1, m plus 2, this is m plus m minus 1, this is 2 m, this is minus 1, this is minus m, this is minus m plus 1, this is minus m plus 2, dot 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 dot. So, I just colored the samples. Suppose from this I take the 0th, mth, 2mth, minus mth and like that. That is, I just decimate it, downsample it by a factor capital M, as I just told you a little while ago, decimation. So, if I just decimate it by a factor capital M, then what I get is this. I get x 0, instead of drawing samples, I am writing the sample values like x 0, and I put a notch below this showing that this is origin. Then I take the next sample, this I decimate means I throw away the intermediate samples. My sample number 1 will be original x m, so it will be x m. Then will be, again I throw away this m minus 1 samples, next I take x 2 m, that will be at sample number 2. So, x 2 m dot 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 dot. On this side I throw away the intermediate samples, I take mth. So, minus 1th sample will be x minus mth dot 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 dot. This is called the polyphase component of 0th order of x n. Is denoted by P for polyphase 0 n, and P 0 n obviously is nothing very simple. If you take x n, decimate by m, what you get is P 0 n, which is nothing but decimated version of x n, very simple. Then what I do, you look at this red color samples, it is a 1, so I form another sequence by picking the red color 1 x 1, but I take origin below this. I am constructing a subsequence. So, x of 1 red colored 1 I take and let the origin be here. Then next red colored 1 is at, if it is 1, it is 1 plus m, m plus 1 is same as 1 plus m. So, m plus 1. Next will be x 2m plus 1 here. Okay, on the left hand side this thing, sorry. This is polyphase component of x n of first order. It is indicated by P 1 n. In general dot dot dot, if I take a general term here, suppose this is kth, this is k plus mth. This is k minus mth, okay, k plus like 1 plus m, similarly k plus m, k plus 2m and all that, k minus m. So, I take x of k and put the origin here like I did. So, next will be x m plus k, x 2m plus k dot 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 x minus m plus k and dot 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 dot. This is a general thing. This is polyphase component of x n of order equal to k. Obviously, k has to be either 1, 2 up to m minus 1. Okay, this is the range. This is the range 1 to m minus 1. So, general thing. Now, you see, look at this P 1 n. If P 1 n I shift to the right by 1, so that x 1 will come to this point. Let me draw it here. First, I plot this P 0 n, okay, and I expand. Suppose I expand P 0 n by m. That means, after x 0 there are m minus 1 zeros, then after x m there are m minus 1 zeros, so on and so forth. Okay. So, what I get is then zeros, then at mth place x m comes, this is x m, between them m minus 1 zeros. So, x 0 here, m minus 1 zeros. So, x m come to its original place mth, then again zeros, m minus 1 zeros, x 2m, so on and so forth. Between them m minus 1 zeros, so x minus m. Okay. For P 1 n, what I do? I say pass it through a delay first. Then expand. Good. Expand. Then what will happen? If I pass it through a delay first, that means origin will move here. Origin will move here. Okay. Or no, let me correct. There is some mistake I am making. first I expand, and then delay by 1. Then what will happen? If I expand this first, between x1 and xm plus 1, m minus 1 zeros will come. Between xm plus 1 to x2m plus 1, m minus 1 zeros will come. Here also. Then if you push it to the right by 1, x1 will come here, x1 will come here, x1. Then there will be zeros because already expanded. At the mth position also 0. Then will come the next point, m plus 1. Then again there will be zeros. At 2m also it will be 0. Then will come similarly here this 0, 0, dot, 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 0, below this 0, but here there is a point. This will shift here because originally I had zeros between them and I am shifting to the right. Okay. So, this fellow will come here. If I add the two, you will see this x0 will come in place. That time it will get added with 0, so no interference. Then x1 added with 0, so x1, this will come up, this will come up. Then zeros and zeros they will add, so I will not get anything. Then xm plus 0, so x of m, this will come up because x of m plus 0 here, and here x of m plus 1 and 0 from here, so x of m plus 1, this will come, so these two will come. Okay. Likewise, x, there is again zeros, then x2m sample has come with a 0 here, so x2m will come up. Okay, x2m here, 2m, this will come up, and again 2m plus 1, this will come up. Similarly, here also this will come up, minus m, and this will come up, otherwise in between zeros. So, if now you take P2n again expand by m and then pass it through 2 delay. P2n, what is P2n, or maybe say PKN, take a general case. What will you get? PKN, kth sample xk and xm plus k. I had m minus 1 zeros. Again between xm plus k and 2m plus k, I had m minus 1 zero, same here. Now, after inserting the zeros, there is expansion, I am delaying it by k. So, xk from origin, this sample will move to kth location. Okay. So, xk, this fellow will come back here at some kth position. Okay. Because I am shifting, I have inserted zeros and zeros and zeros, m minus 1 zeros, m minus 1 zeros, and then shifting to the right. So, xk shifted to the right by k. So, x k from 0 position will go to kth position. So, x k comes back to its original position. M plus k goes to what? I am shifting to the right by k. So, m plus k earlier was at 1. So, it will be going to at what? M plus k. This was 0, this was 1, right? M plus k. Now, all the zeros will come up. Okay, so, m plus k will be at mth position. Then I shifted to the right by k further. When I expand, I have m minus 1 zeros. So, x k is at 0th, x m plus k at mth, x 2m plus k at 2mth, so on and so forth. Then this shift by k. So, x k goes to kth, x m plus k from mth goes to m plus kth, x 2m plus k from 2mth goes to 2m plus kth, likewise. So, that is why these fellows come back. Here also, when you add them, they find zeros from top and nobody else. So, when you add, you get, there is no interference, x 0 remains x 0, x 1 remains x 1, x k remains x 1, like that. So, you can understand that if I take P 0 n just expand, P 1 n expand and delay once, P 2 n expand and delay twice, P k n expand and delay k times. Okay, and lastly, expand and then add them, you will get back this. All right. Yes, very easily, just you take various such figures, P 0, P 1, expand and then insert expand, that is insert zeros, m minus 1 number of zeros between every pair of samples, shifted to the right by appropriate number of indices, like if it is k, p k n, like this sequence, expand, that is between insert new zeros, m minus 1 zeros between every pair of samples here, then shifted to the right by k, same you do here, same you do here, and then add, you will get back easily this one. Okay. Every sample will come back to its original place, one will not overlap with or intersect with, interfere with the other, whole sequence will be constructed. Now, if that be, so this is called 0th order polyphase factor, first order polyphase factor, kth order polyphase factor and m minus 1th order. Okay. Now, Z transform here will be what? If you expand, that is insert zeros, m minus 1 zeros, here it will be original P 0 z to the power m. This is what we have done earlier. Then there is a sequence and that is expanded, that is between every pair of samples m minus 1 zeros are brought in. Then output Z transform will be input Z transform, but Z replaced by Z to the power m. We did it last time. Here what it will be? Z inverse times Z transform here, that is P 1 Z to the power m. Here what will be? Z inverse k times original P k Z to the power m. Okay. That means x z will be what? In z domain x z, x n sequence is summation of them, right? Summation of them. So, x z will be what? This plus this plus this, like that. That means x z now instead of P 0 z I am calling it x 0 z. This I am calling x 0 z. Similarly, this I am calling x 1 z in z domain, of course, and so on and so forth. There I kept P just to emphasize the fact that they are called polyphase factors. That is why I use the letter P, but now I have come back to x 0, x 1 notation, because I am starting with sequence x n, Z transform capital X Z. So, let the components be written in terms of x, capital X 0, capital X. Okay. So, this is x 0 Z to the power m from this one, then Z inverse x 1 from next one, dot 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 Z inverse k x k, this fellow, just capital P replaced by capital X, dot dot dot, lastly okay. This is called the polyphase decomposition of a given sequence x n. This is in time domain, this is in Z domain. Time domain we have seen that is in time domain what we saw, P 0 n expanded, P 1 n then Z inverse dot 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 if I add them in time domain, then I get back x n. If you take Z transform, x z is P 0, capital P 0, which is okay. Instead of P, let me again change it to x. I am making this mistake. Okay, so capital X z is capital X 0 Z to the power m because expanded by m, then plus Z inverse capital X 1 Z to the power m and so on and so forth. This is in time domain, that is in Z domain. This is called polyphase decomposition. Okay. Using this, in the next class, we will show how we can bring down the increase in hardware complexity in a FIR digital filter when you unfold it by say factor 2, factor 3 like that, okay, nicely. Okay, that we will do in the next class. Thank you very much.